So we would like to reproduce here Euclid's classical argument, or what stems from Euclid's work, that establishes that there are infinitely many prime numbers. And this is a typical example of an argument by contradiction. So suppose that there existed only finitely many prime numbers, P1, P2, up to Pn. Okay, n could be a trillion, could be, a trillion to the trillion, I don't know, but there are only finitely many. Or supposedly there are only finitely many. Then consider the number n equals to P1 times P2 times P to the n, P sub n plus 1, which has two obvious properties because of its definition, which is greater than all prime numbers and is not divisible by any prime. That's a contradiction already, because since it's greater than all prime numbers, that means that it has to be composite. If it's composite, then it's divisible by at least one prime number, and we just said that it's not divisible by any prime number. So I could say then this number establishes a contradiction to the hypothesis, to the assumption that only finitely many prime numbers exist. Actually, one does not have to necessarily use a contradiction argument. One could have said simply that if you start with prime numbers P1 up to Pn, then this number here, or any prime divisor of this number, has to be greater than P1 up to Pn. And that again would establish that no matter how many prime numbers you're given, you can always find a prime number which is even larger. So again, that would establish that there are infinitely many prime numbers. So it can be done both ways, and just go with the one that you prefer. It seems that actually the second one, where you just established that given any finite amount of prime numbers, you can find a prime number which is larger than all of them, or that is different than all of them, not larger. It's going to be larger if you have taken all prime numbers up to a certain point, but if you have taken just a bunch of prime numbers, that there is another one which is not contained in those prime numbers. So That would be, I think, a quite beautiful argument. In either way, the consideration of this number is the key in both proofs, and it establishes that there exist infinitely many prime numbers. Actually, you might argue that it gives you a way to, if you like, discover new prime numbers. Of course, this cannot be used in an effective way to give you arbitrarily large prime numbers. And that's it. Thanks for watching.